All right, review 10, last review of the year. Going to roll through these here for you. You got to make sure you're reading all the given information. I'm going to go through it quick. So if you didn't, if you should have already had these done. Hopefully you already read these and did these. Make sure you try them before you watch this video. All right. So in the accompanied diagram, the measure of central angle AOC is 120. The central angle AOC is 120. All right. So if that's 120, we know that the arc is 120 because the central angle is going to equal the arc. We want the measure of inscribed angle ABC. That's this angle here. The inscribed angle is half of the intercepted arc. So half of 120, and that's going to be 60. All right, so angle ABC is 60 degrees there. Here we have a tangent. We have a tangent and a secant. So, and we're talking about the lengths of the segments. So it's going to be the outside times the whole piece, and then that equals outside times the whole. Always remember, outside times the whole equals outside times the whole. So here now see, find AB, so we're going to call that X. The outside piece here is 4. So it's 4 times, the whole thing is x plus 4. And that equals, now here it's a tangent, so it's the whole piece is outside. So it's 8 times 8. The whole and the outside are both 8. The outside's 8 and the whole thing is 8 because the whole thing is outside. Get it? Because it's a tangent. All right, so that's going to be 4x plus 16 equals 64. We're going to subtract 16. 4x equals, what, 48, and then divide by 4. So we're going to get 12 for AB. All right, that's going to be our answer there, 12. All right, in the accompanying diagram, the diagram below, secant segments PR and PT intersect at P. So there's two secants here. PQ is 4. QR is 8. Let's see, this is 8, so the whole thing is 12. PS is 3, and we don't know TS. That's what we're trying to find. So again, outside times whole equals outside times whole. So outside 4 times the whole thing, 12, equals outside 3 times the whole thing, x plus 3. So it's going to be 48 equals 3x plus 9. Subtract 9. 39 equals 3x divided by 3, and we're going to get 13. So ST is 13. All right, back up here, number 4. Now, this picture here, there's a bunch of tangents. AF and AE are tangents. CE and CG are tangents. BG and BF are tangents. They're all equal. So if this is 20, then this is 20. Okay? So that's the piece that we're missing there. So this is 20. Well, the whole thing's 32, see? If this is 20 and the whole thing's 32, this has got to be 12. And then these got to be equal. So if that's 12, this has got to be 12. And then this is 24, so this has got to be 24. All right, so these two pieces are equal, these two are equal, these two are equal. That's how it works with tangents, exterior tangents. Find BC. BC is this whole thing, so 12 and 24. 12 plus 24 is going to be 36. So BC is going to be 36 there. In circle O, chords A, B, and CD intersect at E. Now we're talking about the angles inside the circle. So angle 1 and this angle here are congruent, and they have intercepted arcs. So we're talking about this arc and this arc. Now, angle 1 is 42, so these angles that are equal are 42. This is 42, and this is 42. Those angles are 42. DB is 48. We don't know AC. That's what we're trying to find. So it's going to be arc plus arc divided by 2 equals the angle. That's how you do the interior angles in the circle. Okay, not at the center, but just angles hanging out inside the circle. You add the arcs, you add the intercepted arcs and divide by 2. I only know one of them, so I'm going to say x plus 48 over 2 equals 42, because I know that angle. Put that over 1, and now you can cross multiply. So I have 80 cross multiply 84. I'm going to go up here. 84 equals, and then x plus 48 times 1, right? Times 1 is just x plus 48, and then subtract 48. So you get 36 equals x. So that is the missing arc. Okay, so 36 degrees is our x. Now, this next one here, I really should have provided a graph for this one. So if you didn't get it, maybe you're waiting for the video. So I'm just going to kind of graph this out. There is 1 point, and then 0, 3 is right there. And then 5, 2. And then -1, -2. So if you graph this, you can kind of tell what it might be. You still got to know for sure. It's not a rectangle. You can tell it's not a rectangle, right? A rhombus would have to have 4 equal sides. It's not that. And it's clearly not a square, okay? You could tell of the 4 choices, it's got to be a trapezoid. But a trapezoid has we didn't talk a lot about trapezoids this year. It's just something you should know. A trapezoid has opposite sides parallel. So basically, you do the slope of those two, because you can tell they're kind of parallel. So you just find the slope of those 2 lines, and then since they come out to be equal, I'll just put slopes equal. Equal slopes for those 2 opposite sides there. You get it's a trapezoid, because the other ones don't have equal slopes. Obviously, these are not parallel, right? They're not parallel here. So 1 pair of parallel sides gives you a trapezoid. All right, moving on to page 2. So more with circles here. Arc BC is 60. Well, if this is 60, you see how it's half a circle here? D to C is a half a circle, so this has got to be 120. You got to look for stuff like that. You got to look for half circles, okay, semicircles, and you know that it's 180. The whole circle's 360 if you needed that. In this case, we don't need that. And then we want angle A. All right, so to find the angle outside the circle, it's going to be arc minus arc divided by 2. Remember the other one was arc plus arc divided by 2? Well, now that the angle's outside the circle, okay, it's arc minus arc divided by 2. We got to study this, guys. You got to remember these relationships. And I don't know the angle this time, okay? This time I know the arcs. So it's 120 minus 60, basically. Okay, and then divide by 2. So that's going to be 60 over 2, which is 30. So angle A is going to be 30 degrees. All right, in number 8, same thing. But the intercepted arcs are going to be this. See, it goes to A, and then it goes to C. So it's AC, and then AB. Those are my intercepted arcs. It's arc minus arc over 2. But it's not the arcs they gave. You got to be careful. It's not always the arcs they give. So, but, you know, again, all the arcs got to add up to 360. So if this is 80 and this is 100, I know it's 180. This is going to have to be 180 because 180 plus 180 is 360. So this has to be 180 to get 360 all the way around. So now I know it's 180 minus 80. Okay, subtract the 2 arcs we're talking about, the 2 intercepted arcs. All right, and it's going to be 100 divided by 2 is 50. So angle P is going to be, angle APB is going to be 50 degrees there. All right, a circle has a radius of 4. All right, so let me write this down. Circle has a radius of 4. What is the length of the arc? Length of the arc, that's S, and I don't know that. That's what I'm trying to find. Intercepted by a central angle of 2 radians. That's theta. 2 radians. Now, Because it's in radians, we can just do S equals theta r. If it's not in radians, we can't do that. But in radians, we can. If it was in degrees, you'd have to go x over 360, 2 pi r. Okay? But because it's in radians, S equals theta r. So S equals theta, which is 2, times r, which is 4. So the arc length is just going to be 8. That's it. All right, number 10. We did this one already. This was on a lesson, so you may remember this one. You got to look for stuff like this. The radii are all going to be equal inside a circle. So OH, OF, and OG are all going to be the same. So this is 6, and this is 6. And then FH equals OG. See? It's right here. You got to read. FH equals OG. So FH equals OG. Well, OG is 6, so that means FH is also 6. So what that does is it creates this triangle here where all of them are 6. Got a little bit of a delay here. Hold on. Come on. Come back. Okay. It created that triangle where it's all 6, 6, 6. That's called an equilateral triangle. An equilateral triangle, all the angles have to be equal as well, and they got to add up to 180, right? So basically 180 divided by 3. So each angle is going to be 60. We need that. We need that to find the area of the sector. All right, so I'm going to get rid of that because we don't. It's 60 here, right? That's 60 because all these angles are 60. I want the area of the sector formed by FOH. FOH. So that's going to be this right here. Let me color in what they're talking about. Area of the sector. That's the area of a sector, guys. The shaded area there. That's FOH. So the formula for area of a sector is going to be x over 360 pi r squared. So pi r squared is the area of a circle, but we only want a portion of it. We don't want the whole circle. We just want a portion. And that portion is 60, right? 60 out of 360. So area equals 60 out of 360. We just said it was 60, right? And then pi, and then r is 6. All right, so 60 over 360 pi r squared. Multiply that out, and my area comes out to be 6 pi. Again, I don't type the pi in. Type in everything. 60 over 360, you can reduce that, and then times 36. This is 36. Leave the pi alone, and you end up getting 6 pi. All right, so 6 pi will be the area of this sector. Here's another area of the sector. This time they give us the area of the sector. Same formula though, right? A equals x over 360 pi r squared. They give us area of the sector is 12 pi. All right, I'm going to go down here. So 12 pi equals, that's going to be the A. A is 12 pi equals. I don't know x. It's x over 360. And then pi r squared. R is 6. Pi times 6 squared. So 36x. It's going to be 12 pi equals, this is 36x. This is 36 times x. See? 36x over 360. And then pi. Now, see how there's pi on both sides, guys? When you have pi on both sides of the equation, we've been talking about this. We've done these. Pi on both sides, the pi just, the pi just cancels. So really, you got a thing where you can cross multiply. All right, so you got 36x equals 12 times 360, which is 4,320. And then divide by 36. And you get x equals 120. All right, so it's going to be 120 degrees, or in radians, 2 pi over 3. Okay, either one, 120 or 2 pi over 3, whatever the answers are, whatever they want, degrees or radians. All right, find the radius and the coordinates of the center. So basically, you're just going to need to know x minus h squared plus y minus k squared equals r squared. All right, you need to know that, and then you just compare. All right, so h must be negative 3, h must be negative 3, k must be 2, positive 2, and then r squared is 64. Just compare those. All right, so my center point is going to be negative 3, 2. And my r is going to be 8 because r squared is 64. I just take the square root and that gives me 8. Okay, so my center point is negative 3, 2, and my radius is 8. All right, one more page here. We're almost there. The equation of a circle is x squared plus y squared plus 6y equals 7, and they want you to find the center and radius. So we have to put this in center radius form. Right now it's in standard form. We want it to look like x minus h squared plus y minus k squared equals r squared. That's center radius form. We want to get it in that form. We're going to use completing the square like we did in our very last lesson. So we're going to separate the x's and y's. We don't have anything with the x squared, so we're going to leave that by itself. Y squared plus 6y goes together. We're going to leave room, and we're going to say equals 7. So I just kind of split it up to give us room. There's nothing to do for x squared plus. There's nothing to do. Here, we're going to take half of the 6, which is 3, and then square that, which is 9. So we're going to add 9. And therefore I got to add 9 to the other side. So if I add 9 here, I got to add 9 here. I factor this, and it becomes y plus 3 equals 16. And then I just put it together. X squared plus y plus 3 squared equals 16. So now, looking at this, I can get my center point. My center point is going to be 0, negative 3, similar to number 12 where we just found the center point. And then the radius is going to be 4 because the radius squared is 16. If r squared is 16, then you take the square root and you get r equals 4. All right, so the radius is going to be 4. The center point, you just take the opposite of the constants here. There's a 0 here because it's x plus 0, and this is 3, so it's negative 3 when we do the center point. 0, negative 3. All right, if you didn't follow that, hopefully you get this one because it's basically the exact same process. The only difference now is we do have stuff with x, so it's going to be x squared plus 4x. Leave space to complete the square. Then we're going to go y squared minus 6y, leave space, and then we're going to move that minus 12 to the other side. It's going to become positive 12. So that's the very first thing you do is add 12 to both sides. Get rid of that minus 12. It doesn't complete the square. I want to put a new number here and a new number here. I'm going to actually change colors for this one. So I have 4. I'm going to take half of 4 and square it. And that's 2 squared, which is also 4. I'm going to add 4 there, which means I have to add 4 right there. Here I have a 6. I'm going to take half of 6, which is 3. I'm going to square that, which is 9. I'm going to add 9, and I'm going to add 9. And now I'm going to go back to my blue. Wrong way to do it. All right. And now I'm going to factor. So this is x plus 2. Oop, too fat. X plus 2, x plus 2. That's how you factor. And then it's going to be y minus 3, y minus 3. And then just combine all this stuff here. 16 and 9 is 25. All right, this is going to be x plus 2 squared plus y minus 3 squared equals 25. So there's my center radius form. So now I just find my center point. My center point is going to be the opposite of that and opposite of that. So negative 2, 3. And then my radius is going to be 5. Don't forget to change those signs there when you find the center and radius. All right, now this next one here, there's actually a typo. It's supposed to be 1, -2. Change that to 1, -2. And you're trying to figure out if this point lies on the circle. So basically, you just have to get the same thing on both sides of the equation. We're going to set up our equation. So it's going to be x minus 1 squared, if that's the center point, and then y plus 2 squared equals 4 squared, which is 16. All right, and now we're going to plug in this point. Plug it in. If you get 16, then it's on the circle. If you don't get 16, it's not on the circle. It's that simple. So I'm going to put in 3.4 here. 3.4 minus 1 squared. And then 1.2 plus 2 squared. And then this is going to be 2.4 squared plus 3.2 squared. And you're just going to throw this in your calculator, and you do get 16. 16 equals 16. All right? So, yes. The answer is yes. It is on the circle because it gives you both sides equal. All right. A few more here real quick. Directed line segment PT has endpoints whose coordinates are P, -2, 1, and T, 4, 7. Determine the coordinates of point J that divides the segment in a ratio of 2 to 1. All right, so -2, 1 and 4, 7. Now, if you do there's the segment. It's very difficult to do this on this thing, okay, kind of. All right, so it kind of does this. All right, this is PT, and that's the order I want to go in. It's P first, then T. So I'm starting with P, then going to T, and I want the ratio 2 to 1. 2 plus 1 is 3. So I need 3 parts. So I'm going to take my slope 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 6, 6. So I take my slope of 6 over 6 and I divide by 3. All right, that's going to give me 2 over 2. So I'm going to go up 2 over 2. Up 2 over 2. Up 2 over 2. All right, I'm just going to change. So boom, 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 boom. Up 2 over 2. So there's my 3 parts. All right, and I want 2 to 1 starting with P. PT, start with P. I need 2, and then I need 1. All right, so there's my point right there. There's my point J. My point J is right there because it's that point right there. So that is the 0.25. That is the 0.25. All right, 2 more. All right, so this triangle has these vertices. So -3, -1. Boom, 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 boom. And -1, -4. Boom, boom, doom, doom, doom. All right, so that's B and C. Now, you want to make a right triangle. Okay, it's a right triangle when we have a right angle. A right angle comes from perpendicular, and you should know by now that perpendicular is negative reciprocal slopes. They do give you the y value. They say it's something 3. So I know it's y3. Boom, boom, boom. I know it's somewhere along this line, because that's where my y's are 3. All right, but I don't know where the x is. It's somewhere. I got this right here, right, for one side of my triangle. So I want to kind of go, I want to kind of go this way. All right. Somewhere right there. It looks like it's right about there. So I need my slope. I'm going to go down 1, 2, 3 over 2. Okay, so it's -3 over 2. And then the negative reciprocal is going to be 2/3. So I'm going to go up 2 over 3. And then up 2 over 3. So it looks like we're going to be right here. Right there. And that is the point, boom, 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 3, 3. That's the point 3, 3. So 3 is going to be our x value. You could have also done a right angle from here, okay, up 2 over 3, up 2 over 3, up 2 over 3, but then it would have kind of been a decimal. It would have been like right there. All right, so you could have also done that. That could have been an answer. So it's 3 or 9.5. All right, and this last one here, we have ratios for the arcs. And again, those 3 arcs, AE, ED, and DG, that's half the circle. So we're going to go 5x plus 3x plus x equals 180. That's going to be 9x equals 180. X is 20. So now that x is 20, we know 5 times 20 is 100. We're going to have 100 here. 3 times 20 is going to be 60. And then 1 times 20 is 20. So that's our arcs. We got our arcs right there. 160 and 20. Now, you could start finding some angles. Okay, well, DG, we want that. Yeah, this is just 20. We already got that. AEF, that's this angle here. Now, that angle is alternate interior to this angle. Because see this here, AE is parallel to FD. You got to read that. If I have this and this are parallel, and then I have this transversal right here. See, I have parallel lines. See the Z? Parallel lines cut by a transversal. All right, so that's important because I know this is 30. This is 30 right here because it's half of the 60. So this must be 30. This angle here is also 30. AEF is 30. Now, DBG. Now, DBG is this angle here. That's inside the circle. So DBG, for angle DBG, it's going to be arc plus arc divided by 2. Now, this was 30. Remember, this was 30, so this arc must be 60. That's important, okay? Plus, parallel chords make equal arcs. So if this is 60, this must be 60. All right, that's another way to look at it. So it's going to be, let's see, so I have 60 and 20. 60 plus 20 divided by 2. 60 and 20 are my intercepted arcs for angle B, and that's going to be 40. 80 divided by 2 is 40. All right, so this is 40 degrees. DCA, that's the outside angle. Okay, so the angle DCA, that's going to be arc minus arc divided by 2. So for C, it goes to A and it goes to E. So 100 minus this little one here, 20. 100 minus 20 over 2. That's 80 over 2 is 40. So that's also 40. And then this CDF is this angle here. Now, you got this little triangle. See this little triangle right here? That's how you're going to find that, because you got a little triangle. I'm just blowing it up. We already know B, this angle here is 40. So that's 40. And then this angle we just found was 40. DC, yeah, this is 40. So if that's 40 and 40, this has to be 100. All right, because the 3 angles of the triangle got to add up to 180. All right, so hopefully this helped, and I will see you in class for the quiz tomorrow.